All right, so the last part of 7.4 is actually a very big skill that you're going to need to know how to do in this chapter and the following chapter and the following chapter. How to prove identities, okay? That's next year. But, yes. Strategies.
Mr. G, when do we do Chief?
1. And I'll explain when we do the examples. Pick harder side to start with. 2. Occasionally, this is not always the best option, but if nothing's really working, you could try using conjugate of denominator, DNOM, and I'll illustrate what that looks like, don't worry. 3, this is like the last resort. Work on both sides until they match. Okay, identities is really kind of like a puzzle. You have all these different tools, all these different formulas that you have seen now. You may not have them all really, really memorized, but what we're going to do should make sense, okay? All I have is 2 problems that we're going to go through slowly. The goal for an identity is to use the basic trig formulas that we did earlier and show somehow that one side of the equation is exactly identical to the other side, that they're one and the same even though they look different. Okay? It's not a 2-column proof like you did in geometry where you did all that, if-then statements for the explanations and you had all these different, like, number 1 given, It's not like that. Okay? It's a little different. So, for example, let's say you want to prove that cosine squared theta minus sine squared theta equals 1 minus tangent squared theta over 1 plus tangent squared theta. Okay? Just go with it. Okay? What you will never do when you're proving an identity is do things to both sides, like, oh, let me get rid of this denominator and put it over here, or let me add 6 to both sides, or let me multiply by sign on both sides. You don't do that because we don't know. This is technically a question. We don't know if these are equal yet. We're trying to prove that they are equal. Okay, so we're going to use these strategies up here.
Wait, so will we get times where it's not equal?
No, if it says to prove it, it is.
Okay.
But you can't assume it until you've actually done it.
Okay,
So if you don't get it to work, you've made a mistake.
Okay.
According to this first strategy, which side looks like there's more work to be done on? The right side. Okay? So, in the first part of class today, we talked about how we can change things around so that there's only sines and cosines, right?
Should we do that?
Let's do that. So instead of 1 minus tangent squared, what's tangent? How else can we write that?
Isn't it
Sine over cosine, and since it's squared, we'll do sine squared theta over cosine squared theta. Is everybody good with why we're doing that? Denominator?
1 plus?
We just do 1 plus the same thing. All right? So that's the first step. Now, this is nice because on the left we have cosines and sines. On the right we have cosines and sines, so that's a good sign that we actually have the same functions now. We don't want any complex fractions though, because over here we just have a nice little expression. Can we get rid of the complex fraction somehow? Multiply by what? Cosine squared. Very good. And after we do that step, now we get what on the top? Cosine squared minus sine squared. Very good. Over cosine squared theta plus sine squared theta. Look, we're almost there.
Would the cosines cancel out then?
You can't cancel because you're adding and subtracting.
Wouldn't it just be?
So then you multiply with the conjugate, right?
It's even easier than that. What's that big identity I said we're going to use this a lot?
We just leave it as
Oh, the x squared plus y squared.
What's cosine squared plus sine squared equal? 1. So we're done.
Oh, I get it. That makes sense.
But if you multiply by a conjugate, would you get the same thing?
Well, no. Well,
Cool.
it'll look different, but technically it's the same.
Right.
It's not going to be the left-hand side, but
This is more about using the identities.
yeah. Look, multiplying by the conjugate is like kind of one of the last things you should do if you can't get it to work. The most straightforward method for doing all these identities, guys, is to take one side of the equation and just manipulate until you can try to get it to equal the other side. Okay? It's kind of like a puzzle. You use the formulas you know, and once you get more practice, you'll kind of know some tricks that you'll pick up along the way. Okay? Are there any questions on how we got this to match the left? What is it?
Okay, so I know because we took like what the side of the tangent looked like and used the cos and sine
Yeah.
and stuff. But why did you divide?
What do you mean, why did I
Like
divide again?
1 minus sine squared theta divided by cos squared theta, and then like why'd you divide those?
Because that's what tangent is,
Oh my God. Okay.
right?
You just
Yeah.
Okay.
Light bulb, that's good.
Wow.
Okay, last example, all right? Cosine theta over 1 plus cosine theta equals cosine theta minus cosine squared theta over sine squared theta. Okay. Look, left and right side to me, honestly, look kind of about the same difficulty. The one thing I noticed, though, is on the left, we have all what? All cosines. On the right, we almost have all cosines. We have the sine squared there. So maybe there's a way, so I'm going to actually pick the right side. Maybe there's a way that I can get sine squared to be something else. So let's get going with that. If we do cosine theta minus cosine squared theta, do we have a formula for sine squared where it's equal to something else and it's got a cosine in the formula? Excellent. 1 minus cosine squared theta. So the first thing we've done is played around with the right side a little bit. Yeah, it's that big identity, just shift it around, right? Got to know that and be able to move it around. This is a good thing because on the left we had all cosines, and the right now we have all cosines, right? Is there anything else I can do? I mean, we're not quite there yet. Can we do anything to this to maybe simplify it? We can't cross anything out.
Instead of 1, we write cosine squared plus subtracting.
I like that you want to cancel some stuff out. Generally, before we cancel, we have to factor. Can we factor this at all? Factor out a cosine. What do we get?
1 minus cosine.
1 minus cosine theta. What about the denominator? Can we factor 1 minus cosine squared?
Yes.
Yeah, it's difference of squares. 1 plus cosine theta. 1 minus cosine theta. And look at that. The one now we can cancel these because these are multiplied, right? These cancel out, and we get cosine theta over 1 plus cosine theta. Okay?
That's a neat trick.
We didn't even have to. Now, just because I'm going to do the same problem again and just say, well, what if I did the left-hand side? Okay? Now, on the left-hand side, if I started there, there's not really much simplifying I can do. So here's where we're going to use that second option, which I said you can sometimes use if it might help. The conjugate of 1 plus cosine would be 1 minus cosine. So we're going to multiply that to the top and bottom to see if that helps at all. When I do that, what do I get in the numerator? Cosine theta minus cosine squared theta. On the denominator, this is just difference of squares, but now we're multiplying it out, right? So it becomes 1 minus cosine squared, which is actually sine squared theta. So there's a couple different ways to do this. The point is, you guys, Krista and Abby might do things differently on their identity proof, but it might be right. Okay? Please practice these for homework. Study up for your quiz on Monday. If you